Oh, nice. I'll come look at it after. Yeah, it's good. All right, guys, we're going to start up with morning lecture in a second here, so just wrap up whatever you're doing and we'll get going in a moment. Hey, just checking in with Calgary. Let me know if you guys can hear me and that the stream is coming through to you guys. Great, thanks, Andrew. Okay, so welcome to your first kind of technical lecture, everyone. You guys here in Vancouver, as well as everyone over in Calgary. I'm sure you Calgarians have been kind of notified on how this process is going to work, but for some of your lectures, you're going to be streaming from our live lectures here in Vancouver, and I'll be following along in your guys' Slack channel. So if you guys have any questions while we're going through this, I'll try to keep watch over here and answer anything that you're going through. And of course, you guys here in person, throw questions away. If anything, you can't hear me or anything like that, also let me know in the channel. I'll keep looking. Maybe we'll just start off with some kind of brief introductions. My name's Travis. I studied at computer science at SFU. I took a lot of courses in computer graphics, and that's the programming side of displaying images and 3D models and things on the computer. I like to consider myself a hobbyist game developer. Of course, I'm a web developer. That's the reason I'm here with you guys. And I really like rock climbing. I'm looking forward to seeing you all guys throughout the next 12 weeks. We'll get to know each other. I'll be lecturing and mentoring, so both in the mornings and afternoon. Calgary, I'll be lecturing some of you guys. Shout out to Casey, shout out to Devin, shout out to John in Calgary. I won't have the chance to get to know you guys as well, but I'll make my best efforts. Maybe we can start. Calgary, send me one interesting fact about your guys' group or about any of you guys in the channel, just so I feel a little bit of connection to you. About y'all Calgarians. Well, we're steak. Nice. I like steak as well. So today we're going to be looking at a quick overview of the curriculum that you'll be running through over these 12 weeks. And then because it's a technical interview, we're going to be looking at writing code incrementally. And part of this involves some live coding. And we'll get into the details on what that involves a bit later. But we're also going to look at Git workflow and some problem solving for debugging and getting your programs to work and finding any errors that might come up. But first, yeah, we'll start with the curriculum overview. I'm sure you guys know a little bit about what you've gotten yourselves into, but we're going to break down week by week what will be coming up. And if you guys have any questions as we're going through this, let me know. The first thing to kind of go over is that in every week, capping the end of the week, you're going to have Fundamental Fridays. And this will kind of be, in most cases, a departure from what you've been going over that week. And it'll be focusing on computer science topics. Usually there'll also be a programming test, and sometimes there'll be a chance to research, reflect, and write. And this is just to give you kind of, a lot of weeks you'll be working on a single project. It'll give you a chance to take a break from that and just look at some more algorithm things, some more computer sciencey things, and just really build up those fundamental, strong skills of programming. Your first 2 weeks, so this week and next week, are going to focus on the software fundamentals. The acronym that I like to use here is FOCAL. It stands for functions, objects, conditionals, arrays, and loops. You'll be getting very familiar with all of those over this week. You're also going to be starting to look at the dev approach. So there's the how of programming, but there's also like the environment and the best practices of when you're making these programs. And this has to do with code style, quality, testing, debugging, problem solving. Those are kind of the things that we're going to try and partially address today in our lecture. And then this Friday, for those Fundamental Fridays, you'll have your first programming test. It's going to be a mock test to just get you comfortable with how these tests are going to work, get your set up with the environment for them, and you're going to start to look at recursion. Week 2, you're continuing on these like fundamentals that you've learned, but now you're adding in asynchronous control, callbacks, promises, some stuff on networking. As I'm going through this, a lot of these things like, what the heck is Mocha and Chai? What the heck is a promise? Totally okay, because we haven't started to learn those things yet. We will have the chance to understand them in the next weeks. I think it goes into a lot of detail here. If that's interesting to you, remember it. But if it's not, it really doesn't matter if you remember everything that's going to be coming up. And then you have, of course, another Fundamental Friday with another programming test and some look into object-oriented programming. Once you get into weeks 3 and 5, the pattern of the program is going to be you're developing an application over kind of each week. So week 3, you're getting your first web application, working with kind of the network and actual sending information over the internet. Week 4, you're going to start doing front-end stuff, so the design, CSS, and HTML of that application. And then week 5, you're looking at relational databases. So with web development, the big kind of reason behind web applications is to show and deliver data in a clean way to users. Most applications have a bunch of information, and their purpose is to show that in a nice, approachable way to the user. The way we store data within web development is in relational databases or just databases in general. And so week 5, you're really going to be jumping into what that means. After your first 5 weeks and you've built up the skill set of working with web applications, and you're going to start diving into your midterm project. And this is a chance to kind of compile all the skills you've learned up to that point in a group-based setting. You have some flexibility on which project you choose and how you're going to solve the problem into getting it to work. It says here there's a good real-world prep. And it is, because a lot of real programming jobs, you're working within a team environment, and you're given a set of requirements from your employer to get finished within a certain time frame. That will be very much mimicked by this midterm project. Like it says, they define the teams, the stack. Stack is like the selection of web technologies that will be used, and the requirements, so what the program will have to be doing. You'll be introduced to project management, lifecycle, and collaboration. Those are like the practices that you do with your team. How is it best to make sure that you're hitting your goals on time, that you're keeping track of all of the things that you've done up to that point. You're not going to have any lectures that week, just so you can focus on your midterm. And your Fundamental Friday, you're going to be demoing the project that you will have worked on all week to all of your peers and anyone else who is interested in sitting in. Week 7 to 10, we're jumping back into kind of the normal swing of things, but we're focusing on web frameworks. And now that you've built up all of this kind of base knowledge into making applications yourself, you kind of bring in the big guns and learn web frameworks. And these are these tools that help you to build web applications faster, cleaner, and with more kind of organized structure. Things you'll be looking at is like React. You're looking at Rails, which is another web framework. Yeah, it'll be good times. And Fundamental Fridays are ever present. And then kind of the big exciting endpoint to the bootcamp is your final project. Final project is a little bit different than the midterm in that you get to decide which group you'll be working with. Usually, in teams of like 2 to 4, you get to decide the idea that you want to bring to life. You get to decide, the tech stack that you're working on, the requirements, all of these things, and just put a lot of passion and work over 2 weeks to build something really cool. And the final project is like an amazing chance to like build up your resume and or your portfolio, but it's just also very amazing what week after week the boot camps from Lighthouse Labs are able to accomplish. 2 weeks is like not a lot of time, but the amount that people work and put in, they're able to accomplish quite a bit. And so these are always very impressive. Again, no lectures, so you can focus on your final projects, but there will be some advanced topic lectures. And these are just going to be shorter, hour-long lectures that different lecturers put on around kind of more just topics of interest. It's not curriculum-specific topics, but if someone's very interested in like game development, or someone's very interested in a certain specific topic in web development that isn't necessary, those are what these advanced topics are going to be focusing on. There'll be 4 major solo projects, and this is what I was talking about. Like a normal week, you're going to be working on one project kind of throughout that whole week. So the first one in week 3 is TinyApp. This is like a URL shortener, kind of similar to Bitly. You guys have used that. Essentially, you take a really long URL that you don't want to be sharing with everyone because it's too long. You put it in this TinyApp that you create, and it spits out a nice short, like 20-character URL that you can easily share. Week 4, you're going to be making a Twitter clone called Tweeter. Week 7 and 8, there's a application that works with scheduling interviews built with React. Week 9 and 10, Jungle is like a shopping application. And weeks 9 and 10 is kind of like, again, like job sim week. Jungle will be given to you partially completed. And they're saying, okay, in the real world, you're going to be working on projects that have already been in development. It's very rare that you'll be jumping in like ground zero. We haven't coded anything, and you're going to be making it from the start. So Jungle, in a similar fashion, throws you into a code base that already exists and says, here are some things that you can add to make this shopping application better. Programming tests, there's going to be 7 in total. Starting this week, this week's one, of course, is more of a mock test to get you used to the environment. These programming tests, it's good to prepare for them, but don't over stress about them. They're just as important as the projects, no more, no less. They're a good chance for you to like review and reflect on what you've learned, and maybe identify any shortcomings that you might want to brush up on for the continuing weeks. But don't view them as like you know, a big scary test that if you don't do well on, it means the end of anything. It's just a chance for you to kind of mark your progress and see if you need any additional help, and also a chance for you to challenge yourself and see what you can do given the specific time constraints and environment of a test. Some people do well in tests. You know, if you're someone who knows that testing is not your forte or the area that you perform the best in, just take it as a learning experience and do the best you can. Again, it's not the only area that we're looking for monitoring within the program, so it's not, you shouldn't feel overwhelmed by these tests. There'll be 4 tech interviews, weeks 2, 3, 8, and 9. And these tech interviews are preparing you for eventual job interviews that you will have. Because within programming and web development, in the hiring process, there's often a stage which is a technical interview, where they're asking technical questions, looking at maybe getting you to code a little bit. And these tech interviews are just to prepare you, give you exposure to a range of questions that might be asked in your eventual tech interviews, and to have mentors and lecturers give you feedback and any advice on, you know, how to do an effective tech interview. Quizzes are things that you're going to be looking at in Compass as you do your readings and activities. They're short, multiple choice. You're only going to see them within the first 4 weeks. Again, just a chance for you to see if you're understanding the readings as you're going through them. And then that makes up the total assessment of the program here at Lighthouse Labs. So you have your completion. Are you completing all the activities and projects? Code reviews aren't a formal thing, but they are a chance for you to flag down a mentor and say, like, look at my code. Are there anything that you would improve on this? What am I doing well? What could I do next time? You have the tech interviews we talked about, project evaluations. So for each one of these guys, once you finish it, you're going to formally submit it, and it'll go through a evaluation process where other web developers that Lighthouse Lab uses will look through your project, check to see if it's meeting all the requirements, and evaluate your project based on that. They'll give you feedback on what you could improve, things you did well, and these are really a chance to be like excited and happy and looking for what you can improve on. And it's also very similar to the real software cycle that you would be facing in a job. If you have a job and they are giving you a specific task to complete, the cycle is often you complete it and you submit it for an evaluation to the test team or to other people within your team, and they'll give you feedback. So this is, you know, a nice thing, and it mimics real life. Then quiz answers, test answers, and also your assistances as you're asking for help from mentors. That's another way that we can kind of get feedback on how you're doing. Yeah, it's everything. Any questions on kind of any of this stuff? I think it's like a lot to take in right now. It is a 12-week program, so throwing all 12 weeks at you might be a bit much, but I'll give you these slides and you can look through them as well. Yeah?
Are we going to be able to see like past students' websites, like their end projects, or do you guys not have them?
So the question was, will you guys be able to see past students' like projects and websites? And yeah, there's, you know, pretty much everyone will be posting their projects through GitHub, which is an online repository or place to host your code and websites. And you can have a look through there and see what people have done. Each cohort also has a demo day, and that's a chance for them to showcase their projects to both prospective employees and to the public in general. So for example, next Thursday, the senior cohort, those guys in there right now, will be having their demo day here. You guys will be around the space. You're totally encouraged to come and see the projects that people are presenting and ask questions and things like that. I also encourage you to like talk to them and ask what their experience has been, see what projects they're working on. If you're interested in what they're doing, you know, they can share their projects as well with you. But as you get closer to that final project time, we'll also be sharing other resources things where you can look up previous projects and things like that. So definitely. Calgary, do you guys have any questions? Cool. Again, like I said, there's a lot of material, but take it a week at a time and you'll do great. The other focus of today's lecture is to think about incremental coding. So with your prep work and all of your work up to this point, you've had a chance to kind of dive in and start writing code with JavaScript. Let's check. I think Calgary. Are the demo days in other cities available through the video conference? Yes, I think they often live stream the demo days, so you guys over in Calgary will get to see them. I will double check with some of the people here in the office to see what the process is for you guys tuning into that, but I'm sure you guys can. Let's see. Oh, okay, so seems like David's saying not at the moment, but something that we would like to do in the future. Of course, though, in terms of seeing the projects themselves, we can make those resources available to you in terms of looking at the GitHub and seeing those projects. I would also encourage you guys in Calgary too to, like, if you wanted to, reach out to some of the senior cohorts or even over here in Vancouver and ask them any questions you have on their projects. That would be a good place to start. Yeah. Okay. No worries. Cool. But yeah, like I said, we're looking at incremental coding, and this is the idea of breaking down these maybe larger programming questions that we might face into smaller, easier to understand steps. I guess the metaphor here is like, if our problem is to make a peanut butter and jam sandwich, what are the smallest atomic steps that we can think of in order to complete that task? So we can think of making a peanut butter sandwich as first being able to slice bread, second being able to like open up a peanut butter or jam jar, like third being able to like actually use a butter knife, and then like lastly being able to like spread and put the pieces together. This process of breaking down a more complicated problem into like finer steps has a lot of advantages to it. The first one is it's obviously easier to think about just slicing bread than to think of like the whole process in general. I mean, peanut butter and jam sandwiches are pretty simple, but like maybe we're thinking of a more complicated recipe, like a risotto or something. If I just give you that challenge to like make it on the basis of just that, I at least would be like very confused on where to start. Whereas if I gave you all these like small steps, like first do this very specifically, then do this very specifically, we could probably all walk through and make a nice meal. The other thing is it's easier to isolate and test your code. So if I just start with like slicing bread, or like in programming, if I just start with a single functionality, I can test whether that functionality by itself is working or not. And then once it's working, I can move on to the next step and check, am I doing this correctly? Does it feel right? Is it working? Is it producing the correct outputs? And then I can move on to the second thing. Whereas if I just code everything together at once and something's breaking, it's very hard for me to go in and say, okay, it's happening at this step, because I didn't test each step individually. I'm going to have to like just look everywhere to try and find the error. The other benefit is that you can refactor or improve code as you go. So once we finish one step, we can think back on it. Are there ways that we could do this faster? Are there ways that we could do this cleaner? Is there anything that we can improve on this code? And if we improve on each thing in small steps, again, it's easier than coming back and visiting the whole problem as a whole and trying to identify any improvements that we can do. So kind of for the rest of the lecture, our goal is together to write a node program that takes in an unlimited number of command line arguments, goes through each, and prints out the sum of them. If any argument is not a whole number, skip it. And then also, we don't want to be supporting negative numbers. But quickly an aside on like live coding. This is your first technical lecture. The rest of your lectures are going to be technical lectures, and a lot of them involve live coding. And I think there's like a temptation maybe sometimes to code along with live coding or like try and follow really specifically. That's not going to be the purpose of these technical lectures. And the other thing is like we don't want coding in the lecture context to like look like this, to just be like completely incomprehensible and hard to follow. With lectures, you should be trying to find the like macro or the general concepts of what the lecturer is going through, and they should be trying to give a really good job of talking through the steps that they're going through and talking about why they're making certain decisions and the overall goal of like the demo. These live coding things are not the best places to learn like syntax. They're not the best places to learn like the specifics of how to do something. They're a really good chance to see another developer's process for starting and finishing some code. They're a good chance to ask questions on why they're making certain coding decisions. So don't code along, but we'll try and make it participatory. So if you have any suggestions for me as I'm coding, or if you have any questions on why I'm doing things, we'll bounce stuff back and forth. Like you're not always going to understand everything a lecturer codes, and as the bootcamp continues, that'll kind of become more so. They'll be introducing new syntax and new concepts that you not necessarily have already used or read about. But instead, yeah, you're trying to get that general understanding of what the code is supposed to accomplish, and then you can take notes or remember any things that were unclear to try and do further research or activities that better understand the specifics. So yeah, we'll be doing our best to make these demos as clear as possible. Give as many questions. If something doesn't seem clear, throw your hand up, Calgary, throw a message in Slack, and we'll try and walk through it together. Second aside before we jump into coding is just to talk about Git for a bit. So you guys have had some readings on Git so far, am I correct? Yeah, how do you feel? Is it something that's like kind of making sense, or is it still kind of a big question box for the most part? Yeah, so the comment was, you feel like there's a lot more to it than you know. And that's going to be the case. Git is kind of a big monster. But luckily, you can start with kind of a basic understanding and then build and add more things from there. So we're going to go over kind of the basics of what you should know for this week and next week. But as you go forward in the bootcamp, there'll be more things that you learn on how to use Git, especially with groups and working on bigger projects and things. But in general, Git, it's this repository, which is a system for tracking changes in source code during software development. A couple things that it helps us with, it helps us remember the history of our code, document changes with commit messages, which are just little sentences that tell what we just changed. They also list the author of the changes. For us, in these 2 weeks, we're mostly going to be doing kind of solo programming. So we'll be the only maybe authors on our code. You can also use Git with a remote Git repository that lets you back up your data. So I have my local version of, say, my code here, and then I've also saved it on a remote repository. The one that we'll be using mostly is GitHub. And so if anything happens to my computer, I still have all my work and backed up on GitHub. It allows you to undo changes that you've made. So if you're coding and you just break the whole project and you don't know where to start in debugging, you can kind of jump back a step in your save. It also will make it easier to collaborate with others on code. And this is one that you'll kind of get more experience as you move closer to, like, say, the midterm and more of these group opportunities. For now, most of these benefits will be the main ones. There's so much more that Git can do, and I think initially maybe it's a bit daunting, but it is such a helpful tool. So stick with it and try and do research and ask a lot of mentors for help on Git. If it's throwing you weird messages and you're not understanding what it's doing, they'll be very helpful and have a lot of understanding of using the repository. So this is just a kind of helpful diagram for how Git is working, or how the Git commands help us to save work in our project. So when we make a Git project, we have a working directory, a staging area, a local repository, and maybe a remote repository. This working directory is what you see in, say, your code editor. So I have VS Code open here. I can look through all of my, these are like notes on lectures. This is all saved as a Git repository. But just this file itself, all of these things are representative of my working directory. They're the files themselves on my computer. If I don't have a Git repository at all, I still have a working directory. We're all familiar with the working directory because that's just the basic files that exist on your computer, regardless of if you've initialized a Git project. This local repo is the history and like saved files for, this is like essentially Git. So when you create a Git repository and you save your files to it, they exist as like a file save within your local repository. The staging area is kind of a temporary area before you add things to the local repository. I like to think of the staging area as like an airlock. So if you're in like a space station, maybe inside the space station is like your working directory. And then you're like, okay, I want to like move all of this like working directory or part of this working directory into my saved like Git repository. So you put the things that you want, you organize them in this airlock. You can check the airlock and see that like all the files are there that you want to be moved into your repository. And then you let them out of the airlock and they're into the local repository. Yeah.
So essentially the local repo is like a backup and the remote repo is remote backup.
Yeah, so the comment was like, essentially the local repo is the backup and your remote repo is like the remote backup. So this is, your local repository is a backup. It also serves as like a history of all of the changes and saves that you've made to your project. So your local repository, I'm not going to be able to, your local repository is like a long chain of saves. So you have your initial save here, and then later you do another commit, and then later you do another commit. And it's this chain, this history of what your files have looked like over time. So at this node here, maybe your files were just empty because you're starting the project. Here you've added your first function to do something. Here you've added a second function. And so you can look back and see how your project has evolved. And you also have the option to like jump back to certain things, you know, again, if something had broken or anything. And the reason that you have this, like, I think this staging area is what causes the most confusion when people are starting with Git, because it's like, instead of just saving something to the local repository, you have to do a git add, and then you have to do a git commit. The git add is the staging area, and then the git commit is to actually save it. So if you do git add, and then you like change a bunch of files and do something, it hasn't actually been saved to your local repository. And the question then maybe is like, why have this staging area? Why can't I just like save everything in my working directory right over to my local repository? Why is there like an intermediary step? And for a lot of cases, like it isn't needed, but the reason the staging area is here is so that you can, again, if you think of it as a like airlock situation, you can put some of your files that you want to be saving, and you can check out that you have the right files and they're in the right state that you want before you put them into the local repository. It just gives you an extra stage to check and make sure that you're doing everything that you want. In the case maybe where you're just adding all of your files right to the local repository, you don't really care too much. You can just like skip over, maybe quickly just go git add and then git commit. We'll look at some of these commands and we'll go through a bit of a initialization for our project in a second here. But git init, that's the command that's going to start your repository. It builds the repository in your folder. Git add, this is moving any of your files in your working directory to that staging area. And then git commit is going to save those stage files to the local Git repository. You can use the keyword remote to add a remote repository. And then once you have a remote repository, you can use git push to move your local repository to your remote repository. And that will just update. So you have your kind of chain of saves here, one save, and then you have the same history in your remote repository, but maybe it's behind a step. When you git push, it updates so that it has the same history as your local. So that's pushing. Takes it from your local to your remote. Your basic Git workflow for these next 2 weeks is going to be to initialize a project, add all of your files to that project, commit all your files, and then push. There actually will be one extra step in here where you're adding the remote. But let's jump. I think we've done enough looking over. Let's jump into what that's actually going to look like. I'm just going to navigate down into the correct folder. I think we're in lectures. This is week 1, day 2. We are going to make a new directory or a folder. We're going to call it code. And this is where we're going to do our goal of making that node application that takes in command line arguments and adds up all the numbers if they're correct numbers that are given. To initialize our Git repository, well, first we need to change the directory into this new folder that we made. So we'll go cd for change directory into code. Now we're inside this code folder, and we can do git init. So it says initialize an empty Git repository in this folder. And if I do ls, and so ls is to list all the files wherever I'm at, and I can do this flag lah will show even hidden files. I now see that there is a thing .git within this folder, and that's the repository. Once you initialize this Git repository, you never have to do anything with this folder here, but you can check to see if it's there once you've initialized, if that's something you're interested in. The next step, I want to set this project up so it has my local repository and a remote repository with GitHub. And to do that, I'm just going to go to GitHub. And this is, I'm already logged in. So right on my home page, I have the option to start a project. I click start a project, and I can name this anything I want. So maybe I'll do week 1, day 2. And hit enter. And at the top it says, this is my quick setup if you've done this kind of thing before. And it gives me a link. There's the option for HTTPS or SSH. When you're using GitHub, you can use either of these options if you've done the correct setup. The difference is SSH is going to check for some keys that you've set up on your computer and match them with the keys that GitHub has associated for your account to verify you. So it's going to say, oh, are you the correct user that can be adding stuff to this repository? And it does that all automatically. The difference with HTTPS is that it's going to make you manually verify yourself. So if I use the HTTPS link, it'll ask for my username and my password so that I can push stuff to this repository. Use SSH if you have it set up, like the Lighthouse material tells you to set up those keys, and it'll just save you time. I'm going to use HTTPS just to show you that either will work. I copy this link, and within my terminal, inside the folder where my repository is initialized, I'm going to go git remote git remote add origin, and then I can give it the link that I copied. And what this is saying is so add a new remote, and I'm naming that remote origin. This is like standard practice with GitHub and your local and remote repository. Your local one, you always call your remote, well, you call the main remote repository origin. With Git, you have the option to be adding more than one remote repository. For most cases, you're not going to have to do that, and in a lot of the projects and things you're going to be working on, you don't need to. But that is an option, and that's the reason why you specify the name as kind of the fourth parameter in this command.
What does it mean to have more than one repo? Like, what could be a use case for that?
Yes, so the question was, what does it mean to have more than one remote repository? What would the use case be for that? So one use case maybe is me and my team are working on a project. We've set up one remote repository in GitHub so that on our separate folders, we all have access to the project. We can pull it, see what other people are making changes on, and we call that origin. So we have all of our things, and then we have one single origin that we all get stuff from. You can set up, I'm sorry for these like really bad drawings, but maybe they help a little bit. You could have like another remote repository. Just the use case I would think of is for deployment. So for instance, there's like hosting sites like Heroku or other, I mean, we don't have to go into this too much right now, but essentially it's another server online where you can push your code and it will be accessible to like the public. It'll be accessible as like a application that anyone can use. So you have your one repository here, or remote repository, that you're always pushing to and pulling from for the team to work through. And once you have a version that's like up and running or works, you might all push to this second remote repository whose only purpose is to serve the content to users. There are other use cases where you might have two remotes or something. I mean, like if you just wanted to have one remote with one team access to it, another remote with another team access to it. It depends. But like I said, for most cases, you're only going to have that one remote, and it's common to call that remote the origin. So if I hit enter now, and I go git remote, it shows that I have one remote called origin. I don't have anything in this project right now to kind of add or save. So maybe the first thing we can do is I can use touch, which is a command to create a file, and I'll make, what should we call our project? What might be a good name? Sum.js. So now I have one file in kind of my working directory. I have nothing saved to my Git repository. To save stuff to my Git repository, I first have to add it. And with the add command, there's a couple options. I can choose a specific file to add. So if I do git add sum.js, it's going to add it to the staging area. The other option maybe is if I just want to add everything that's in the folder, I can use a dot. And this is essentially git add all. For this case, I'm just going to tell it to add that single file. The other command that you will find helpful is git status. And this will tell you kind of what is in your staging area or any other information on your repository. So it says I have no commits yet for this repository. I have some changes that need to be committed. And I have one new file, sum.js. Next, I can go git commit. And like we said, all commits have this message that goes with them so that I can tell myself and anyone who's looking at the code why I'm saving at this stage in the project. If I hit git commit and just hit enter, it's going to bring up a like command line text editor, so I can type away and use commit messages. It's kind of annoying to use, so often you'll do this -m command, which means I want to give the message right here instead of having to do an extra step. And I can just say, this is initializing the sum demo. So we see that I added this one commit. And finally, the next step is to push it to so if we look at our notes, right now we have our working directory. When we created that sum file, we did git add, we added it to the staging area. We committed with that commit message to local repository. Now we want to do a git push to send it to the remote repository that we linked. So I can do git push, and then I have to specify 2 parameters for where I'm pushing to. So I specify which remote I'm pushing to, origin. It's the only one I can because it's the only one I have, but I specify origin, and then I specify which branch I am pushing to. Now we haven't looked at branches, and it's not something that you're going to be using maybe too heavily within this first week, but when we were drawing that tree in the Git repository, or about the Git with all these like previous saves, a branch is the option to take this same Git and have multiple kind of paths or save histories. You won't be using branches right away, but the thing to remember is that the main history line is called master. So what I'm doing here is I'm saying push everything in this Git repository to the remote called origin, and only push the master branch. I don't care about anything else because we're only concerned about master right now. That's only what we'll be working in. Oh, I didn't put a space apparently. So because I used HTTPS, it's going to ask me for my username, and then it's going to prompt me for my password. And it looks like it was successful. If we go over to the GitHub page for that project and I refresh, I now see that there's one file here, obviously with nothing in it right now because we didn't add anything. But now we have the local repository and the remote repository set up. And from now on, we can kind of just follow this pattern of going add, commit, push, add, commit, push, anytime I make a change of significance. Yeah.
Are there any complications if you have one Git init in another Git init?
Yeah, that's a great question. So the question was, are there any complications if you have one Git init like nested inside of another Git init? So maybe the example right now is I have this code folder, and then maybe a directory above, I do git init of this folder. Now I have one Git project, and inside that Git project, I have another one. That is something that you're going to want to avoid for a bootcamp. It does have some weird things that occur when you're adding and committing things and then pushing it to the remote repository. In general, the idea is that you have a singular Git repository per, say, project. So you guys are going to have maybe a similar folder structure to what I have here, like week 1 folder with day 2's activities inside of it. The temptation might be to initialize a Git project or a Git repository within week 1 and just have all of week 1 pushed to GitHub. Don't do that. Just initialize a Git repository per, say, you'll have like activity 3 or 4, and your Git repository will be local to that. It's going to seem maybe a little bit tedious initially because your activities might be fairly small or short, and it's like I'm just making this single file for an activity, and I'm having to like initialize a Git thing, add this remote repository, push it, For one, that will be good practice. For two, as you go forward and your projects get bigger, that doesn't become such an issue. With a bigger project, you're only initializing once. You're working on that project for like the whole week or maybe longer, and then you're just doing pushes and adds, commits, and pushes as you work through it.
If you do accidentally like dig Git init in another init, is there a way to remove that, or do you just delete the .git?
Yeah. So the question was, if you do accidentally do that nested thing where you have a Git inside of another Git, is there a way to remove it? Yeah, you can just like remove the .git file itself, and that stores all of the information on the Git. That's a good approach, and that'll remove any of the complications that you might have had through nesting them. Yeah. Any other?
If you initialize with HTTPS and then wanted to change it to SSH, is it possible to do that without? How would you do that without like destroying it and then reading it?
Yeah. So the question was, if you I initialized say with HTTPS. What if I wanted to go back and use SSH so I didn't have to give my password and username every time? Could I do that without like destroying the remote? You can, because the remote now exists independent of the link that I've created. So I have my remote and I have my local, and I set up a link between the two of them. Even if I destroy this link, so we get rid of this, that both of them still exist. So you would just reset up. Here I did git add, or no, sorry, git remote add origin, and I gave it that link. My first step would be to remove my current link to origin, and then I would just do this process again, git remote add origin, and give it the SSH link. I actually don't know the command off the top of my head to remove a remote. Remove remote. Here the comment is, instead of removing and re-adding, you can reset the URL for origin. You could also remove and add, but I guess this would be a better way. So git remote set URL origin, and then in my case, I would just paste the SSH link for this one instead.
If you had to insist on deleting it.
Sorry?
It says if you insist on deleting it.
Oh yeah. So I guess the option I initially thought of would be this one. Git remote remove origin, and then you would do git remote add origin and the new SSH one. Cool. Any other questions? Any questions from Calgary? If not, we're going to jump into kind of working through our activity now. So if we look in my directory, I have code where my Git project is initialized, and I have an empty JavaScript file called sum.js. And maybe if we just go back up in the notes and look at our goal, we wanted to write a node program, takes in an unlimited number of command line arguments, it goes through each one checking if it's a valid integer, and then adds them together if it's a like whole positive or negative number. So my question to you guys is, what are the kind of maybe basic steps that we can break this problem down into? What are the steps that we need to do to be able to complete this functionality?
Grab all the arguments.
So we need to first grab all the command line arguments. What else? Change the arguments into numbers. And then what? Call a function to add the numbers. So I encourage you to start your programming from this kind of place of just pseudocoding or coming down with the tasks that you need to hit. And right away, we have kind of maybe 3 functions that we can create independent of one another, see if they're working properly, and then combine them together to get our whole program to work. Within these 3 more general functions, are there any specific tasks that we can maybe break down into further steps? Or are they small enough steps as it is? What do you guys think?
You break them down, like for the command line arguments, you would say you want to discard the first 2.
Oh, nice. First 2 arguments. So we'll look at that in a second. How do we go about changing? Because actually, we want to change the arguments into numbers, but there was an additional requirement that was like, we only want whole numbers, well, essentially integers, positive or negative whole numbers. So maybe another step is to check if the argument is a valid integer, and then call a function that adds the numbers. Maybe this involves looping through the arguments / numbers. So now we have these 3 things that we're going to start working on. I think we're actually going to break here for about 15 minutes. So come back at 11:10 or so, and we'll start jumping into each of these kind of function stubs and seeing how we can make them. Actually, before that, what we can do and what we're going to want to be doing with our projects is we can just git add. I'm going to add everything, git commit, and I'm just going to say broke down the problem into functional steps. Great. When you're working on programs or when you're working on your projects, commit often. Anytime you like get some level of code that's working, add a commit. You don't have to push as often if you don't want to, but I could also do a git push right now if I wanted to. Committing often though is very important. Cool. So I'll see you guys back in 15 minutes or so. And if you think of any questions during that break, just bring them up and we'll start by answering any of those. second now. All right, Calgary, just checking back in with you guys. If the audio is coming through again, we'll be starting back up in a second here. Can you guys hear me? You said there was a lag earlier. Hopefully it's not too bad now. Thanks, Devin. So we left off and we had just created these 3 steps into solving our problem. And let's start maybe with this first one, grabbing all the command line arguments. We're going to want to make this as a function. So we'll call it maybe just get arguments. And this is going to equal a function. And we want this function, when we call it, to, we don't need to give it any parameters, but we want it to return all of the command line arguments that the user has given us. Arguments, maybe, we'll call it. And there is a way to get arguments within the command line as someone executes the code with process.argv. You guys might have used this in some of your activities up to this point, but if not, it's just essentially going to grab anything that the user puts on the command line as they're writing node, whatever the program is called. Part of this demo, we're going to be seeing what are ways that we can be debugging the code or kind of peering into the code as it goes so that it makes sense. So before we do anything further, we're going to test this function as itself. So we want it to return arguments. And we'll just do a basic test. We'll call this function. Actually, we'll console log the return of this function. So get arguments. We're calling this function. It's going to do process.argv, return it, and then we're going to be printing that kind of to the terminal. So if we save this step, open up our terminal, and go node sum.js to run our program, and we give it some extra things. 1, the actual number 2, and then dog. Our program is printing out what looks like an array because it's starting with an opening square bracket and ending with a square bracket. And there are 5 things inside this array. But what we see is the first 2 things. The first one is a path to node, and the second one is a path to sum.js. And then after that, we're getting 1, 2, and dog. Our program wants us to get the user input. And these first 2 ones, it seems that it's giving us, are from here. So we don't really need those. We just want the dynamic ones that the user can enter after the fact. 1, 2, and dog. So that was kind of, I guess, the comment we had earlier that we needed to discard the first 2 arguments. But just by console logging at this point, before we do anything further, we can kind of get an idea of whether or not our function is working. And we just discovered that it isn't, because it's giving us those extra 2 that we don't really want. You guys remember a method that we can, cut off those first 2 ones from this array? Slice, yeah, so the comment was slice. We can use slice, and then slice takes a parameter. It says right here, the index of the beginning of the specified portion of the string, or portion of, so it's going to return a section of string or a section of an array. In our case, we want to start at the after the second element and keep everything after that. So we can go slice of 2, and we'll get, if our array was 1, 2, or actually our array wasn't this, it was that node path, and then it was the program path, and then it was those other things. We're saying starting after, or starting at the index of 2, keep everything from there on. So 0, 1, 2, we're slicing from 2 onwards, and we're getting this smaller array. So then we can test our function again, and it looks like it's returning an array with just 1, 2, and tog, the things that we want off of this command here. So at this point, we have a function that's working according to kind of our initial plan. Maybe we can then think about refactoring it. We say, okay, it's working at this point. Can we make this code any clearer or any simpler? And one thing we can do right off the bat is we're saving the arguments to a constant variable called arguments, and then we're returning it right away. We can save one step by maybe just returning the arguments right away instead of saving them first. And then we can take this line and just get rid of it. And then, of course, just to be sure, we will test it again, and we have the same output. So at this point, we can be kind of maybe happy with our atomic step, our function that we created. It seems to be doing everything we need. So we'll celebrate by adding everything, and committing everything. And we say finished get arguments function. We'll hop back over to our code, and we can jump into the second thing that we were looking at. Yeah?
Is there any reason you chose to make that into a function?
So the question is there a reason that I chose to make this into a function? Of course, I could have just had, I mean, it's one line. I could have, just saved arguments equals process.argv.slice, and then used it later on. The reason I chose to do it in a function is because when I do things within functions, it makes them like reusable. Right now, we're only having one goal. We only want to do this, get all the arguments and sum them or whatever. But if I create this within a function, this is a piece of code that if later I need to get the arguments from a user, I can use again. Whereas if I just hard code it within the file itself, it's not as dynamic. It doesn't let me use it in more than one case. And just as planning ahead, I'm thinking, well, maybe I might want to use this later. Also for readability, if someone else is looking at my code and they look at this function, it kind of makes sense as to what it's doing. And if when I'm using it in other places, it'll be cleaner when I just call get arguments as opposed to writing this whole line. Although this, of course, is a very simple function, and there are cases maybe where I wouldn't want to have to put it within a function. I could just get the arguments themselves. But I guess the point we're trying to illustrate here with doing this atomic programming is let's make little functions that accomplish things and we can test them, and then let's add them together as like building blocks. It'll probably see the advantages will probably stick out more as we go through these next ones. So this function, we'll create another one. And we want to change the arguments into numbers. We're also checking if the arguments are like valid integers or valid numbers. What should we call this function? Change. Numberize. Sure, we'll do numberize. And again, that's going to be a function. But this time, we do want to take in some parameters. And what are the parameters that we need? Sorry? Yeah, well, we can call get arguments as the parameters, but in more general, it's going to be an array of arguments. And then somehow we are going to need to kind of go through each of these arguments and check whether, one, they're like a number, and two, maybe they're a whole number.
Can I have a question? So
Yeah.
normally when I do this, I would describe the argument by the data type. So if this function takes an array, I would call that array. Like is that something?
Yeah.
I guess is that a good practice, or is that something that?
So the question or comment was that normally when they're making functions,
When I do it.
yeah, you can. Is it good to like say name this according to the data type that would be passed in? So we could call this array or something like that. I think it depends. In general, with your parameters and variable names, you want to be as descriptive as possible. So array does communicate a good thing. Well, actually, I think it's not. Array can be reserved sometimes. So a lot of people do ARR or something like that. But in our case, it's an array of arguments. So my choice to do arguments was, and then because it's pluralized, it gives the idea that it's longer. But if I want to specify that this was an array, I could do something like array arguments or something like that. It is up to you, and calling it an array might be helpful. Especially actually if we're going to be using this in other cases. But yeah, the rule is to be as descriptive as possible. The thing you don't want to do is to just say, we're going to take in one parameter and it's going to be called like x. Because then when I'm reading this code, I have no idea what this is. It's really hard to understand what should be passed here. But just try and be descriptive, and if it's making sense to you, then that works. But like kind of a rule is if I hide any information on what the function is doing, and I can't understand what anything is meaning, then I should have better naming structure. Next, we want to probably loop through each of the arguments or each of the things in the array, so we can check one at a time if they're a valid integer. So we're going to use a for of loop. It might be something that you've seen. It might not, but we'll look at it right now. For of is just a special loop that helps us loop through arrays. And so I specify a new variable which will represent each thing in the array in turn. So if our array is 1, 2, dog, for my first loop, argument will represent 1. Second time it loops through, argument will represent 2. Third time, argument will represent dog. So even just to start, before we do anything else, there's another way that we can kind of debug or check the workings of our function. We could do a console log here and say console log argument and kind of see what it's doing. The other thing we can do is we can put a debugger. Debugger. And for some reason, my linter is removing the debugger when I say, so I'm just going to turn it off right now. So this ESLint, you guys have seen that you can ESLint from the command line. I just have a VS Code plugin that does some linting for me. Linting being the highlighting of kind of proper structure to my code, not syntax things directly, but so that my code is neat, that I have spaces before and after things like this. So it's saying like, hey, you should have a space there. But right now it's getting rid of debuggers, so I don't want that. Okay. If you want to reload ever, you can go Control-Shift-P, and we can type reload. It's right there, but if I can type reload window, and it'll reload for me. You can also like close and restart the editor if you want, but that wouldn't be as nice. Debugger. Okay, there you go. And then when I have a debugger placed within my code, I can run my program with the keyword inspect. Actually, we shouldn't do that yet because I'm not even calling this function. So I'm just going to comment out my other test, and I'm going to do a new test for numberize. And I'll go test array equals, and the reason I'm not using get arguments is because I want to test this new functionality separate to anything I've done before. So again, I can isolate any errors down to this function. And we had 1, 2, dog as our kind of test input. And we want to call numberize on our test array. So what is going to happen is when I run sum.js with this inspect keyword, it's going to run through the program but stop any place that I put a debugger, and it's going to give me a full command line read, evaluate, print loop that I can write any JavaScript code, but it's within the context of my program, so I will have access to any functions and variables that are defined at that point where I put the debugger. So I hit enter. The first thing I get is it's breaking on the first line of code within my project. That's not where I put a debugger. It just does that by default. And I can say continue to the next debugger part. And then we see that it's stopping here on line 13 where I put this debugger. Next I can, oh shoot, inspect, no. I can look at maybe argument. Oh shoot, let's see. Node inspect REPL. So what I'm looking for is it's breaking at that point, but I want to be able to go in and write JavaScript myself to next, step in, out, pause. Okay. Let's. I don't. Argument. Oh, I know. Let's check. Node? Nope. Sorry, guys. Node debugger. If anyone wants to look this up too, we can figure it out together. But I'm just, I'm looking for the command that lets me jump into the code once we are inspecting everything. Oh, okay, here we go. So we inspect, we hit that first breakpoint, that's automatic. We can go continue, which will go to the next breakpoint. And I hit C for console. Should console, nope, help. Oh, it's just REPL itself. Okay. So we'll get out, run it again, first breakpoint, second breakpoint, and we'll go REPL. So REPL stands for read, evaluate, print loop. And we have this, I can run any JavaScript in here, so I could go const thing equals 2, and then I can look what thing is. Our console log thing. Thing is not defined. It's not liking my definition there, but let's see if I console log arguments. If we're getting context there. So within my code, because I've stopped here, I have access to any functions and variables which I have declared and which are in scope at this point. So argument is in scope, array arguments is in scope, and I can test and see what is happening. So if we go arguments, I saw this because that was defined here. Where's? Yeah, that's
weird.
So I'm not sure why it knows what arguments is, but we can also log. Yeah, like a keyword. But we have argument, and that will be 1 because we're in the first loop of our breakpoint. We can also console log array arguments, and we see the full array that we're like looping on. So this was array arguments, which was passed in here, and then I can exit out of the read, evaluate, print loop, and then I can hit continue, and it'll hit the debugger again because it will be on the second loop. And then if I console log argument this time, oh, did I not go REPL? Okay. If I console log argument this time, we will see 2. And then I can get out of that and then continue to the next one, jump down into the loop, the read, evaluate, print loop, and console argument again. And we get the last one, dog. And if I continue again, I'm not going to hit the loop because it will finish, and it's saying waiting for the debugger to disconnect. Meaning I finished all the code, and I can exit with Control-C, Control-C. So debuggers, I find very helpful with loops and things when I want to check in nested code to see multiple variables that I'm checking. Of course, I could have done a console log of argument and a console log of array arguments, but then my console is maybe going to look a little busy. If I run this without inspect, I get 1, 2, dog. I mean, it's kind of simple code at this point, but this doesn't give me as much information on like how the code is executing through, whereas a breakpoint will trigger each time and let me to see the information as I'm going through it. Okay, but back to what we're actually trying to do. So now we know this will represent each argument as we go through, And our first thing is we want to check, or it says change the arguments into numbers. So one way we can do that is we can go we'll call this like maybe a number. And there's this keyword number, which is a built-in object type in JavaScript, and we can use it to take any parameter and convert it into a number type. So we can go argument. If this is successful, it will result in the actual number. If it's not successful, it's going to return none, which is a type that represents this. It's not a number. It's also a falsy type. So we can do testing on this new argument or this new variable, maybe number, to see is it true, is it a real number, or is it falsy, is it not a number. So that could be the first step that we check. We're going to check if argumnet. So we're going to check if maybe number exists, then we want to do something. But if it doesn't, or not if it exists, if maybe number is a real number, then we want to do something else. It's going to be not a number. We want to do something else. So if it is a number, what is the next thing that we want to check? Yeah, so we want to check if it's an integer. And what we can do, there is a method or function that we can call on numbers to see if they're an integer, and it's isInteger. And this function is going to return a true or false depending on whether it's an integer or not. So we could probably do like another if statement. If this maybe number thing is an integer, then there's something that we want to do. Otherwise, we'll do something else. So change the arguments into numbers. We have our checks in place, but how do we want to store all these new numbers? We can't just return a single thing. Like if it is a number and it is an integer, maybe we would go return the maybe number. But that would just have us returning a single number. We need to get all of the possible numbers from our array. So instead, before we even jump into the loop, we're going to create a results or maybe an integer array. And it's going to start with nothing in it. If it is a number and it is an integer, then we maybe want to add this argument to the integer array. One way to add things to arrays is to do a push, and then we pass the thing that we want to add to this array. So we want to add a maybe number. If it's not an integer, so this is the case, it is a number but not an integer. And this is the case where it is not a number. So what do we want to do in the case where it's not a number, or it's not an integer, or it's not a number? We can probably handle these similar, but what might be a way of handling both of these kind of error cases? So one option is to do nothing. We could console log error not an integer. Or here, error not a number or something. We could do nothing. Kind of depends. But after we loop through everything, so here we are probably going to want to return the results. No, we called it integer array. Integer array. Integer maybe will be the number for each loop, but then we're taking that integer maybe and we're pushing it into an array, which will be all of the results. Okay, so we have something of a skeleton. We can try and see if this is going to work. So we already have numberize on these three things. We're calling it, the one thing we're going to add is we're going to console log the result of this and see what it's returning. Number is integer, is not a function. Let's double check the syntax on that. JavaScript is integer. Oh, yes. So similar to how here we're using this like number object to create a number. We don't want to call it on the number itself. We want to go use that number object, and we want to pass in maybe number as a parameter. So we get 1, error, not a number, 2, dog, error, not a number, and 2 again. So our console log is pretty messy right now. So let's go back and kind of clean it up so we know where everything's coming from. We'll keep these 2 error console logs. We'll get rid of this one within the for loop, and we'll keep the last one that just prints our output. And so we get 2 error, not a numbers, and then we get a output of just the number 2. That seems okay. Our requirements didn't say that it needed to break when we didn't have it handle it a number. It just said it would take all the ones that were numbers and add them together. So we are getting all the ones that are numbers. We're getting a little bit of user information to let them know that some of them weren't a number, which is okay. We'll leave that in for now, but it seems like our function is doing decent. If we wanted to, we could clean this up a little bit. We have a nested if statement in here, and we're checking if it's maybe a number, and then we're checking if it's an integer. What we could do is we could copy this and move it to the same check up here and say if it's a number and also it's an integer, then we want to maybe add it to that array. Else, we'll console log error not, and we'll just give a more general error. It's not an integer. Because in this case, it could be either not a number at all or not an integer, so we'll just loosely say it's not an integer. And that cleans up our code a little bit, and that's probably good enough for now. Again, we finished another function in our steps, so we can go git add all, git commit -m, added numberize function to check array of arguments. We will get rid of our test code. So we can comment it out for now. And we'll jump on to our last function. So lastly, we want to loop through all of the arguments, and we want to add them if they are an integer. And we can make use of course, the 2 functions that we've created up here. Maybe we'll call this sum arguments. That will be a function again. It's going to take in similar to numberize maybe. actually, let's have some arguments just take in an array of integers that it can sum. So we can go sum arguments is an array of integers to keep it simple. So sum arguments takes an array of integers, and we just want to sum up all of everything that's in this array. We can have maybe a similar structure to our last function. We'll for let integer of the array of integers. And for each integer, we want to add it to maybe a tallied sum. So we'll have, again, when we want to store information that lasts beyond the loop, we have to go outside of it. So here we can go a new variable, we'll call it total. It starts off as 0. And then as we're looping through our integers, we can say total plus equal, or that's the same as equals total. So whatever its original value is plus some new thing. So if we go total plus integer, but we could also just go plus equals. And once we have looped through all of the integers, we can just return the total. This function is a little bit simpler than the last one, but we can still do a quick test on it. Let test integers equal. Our assumption is that anything that's passed to this has to be a real integer, so we're not having to test for fake stuff right now. We'll just do 2, 3, 4, 5. And then we'll console log some arguments on our test integers. Exactly. We run our code. Oh, that wasn't running our code. We run our code and we get 14. So we look 2, 3, 4, 5. It's 14, so it looks like we're doing good. Doesn't look like there's much we could do to refactor here unless we find the sum of this array in a different way. At this stage, we have our 3 functions. Actually, if we want, we can do another commit. Say sum integers function added. But now we need to see how to put all these pieces together. So the first thing we're going to need to do is we're going to need to get the arguments. And that was our get arguments function. So arguments will be a list of arguments from the user. Then the second thing we had was we want to numberize all those arguments. So this will give us an array of integers. We can call numberize on our arguments. And then lastly, we'll get the total from some arguments on our array of arguments. And then we can console log the total. Sorry? Yes. So we want to pass array of integers. So we're getting the arguments from the user. We're passing those arguments into numberize, which will return an array of integers. We're going to sum all of those integers up into a total, and then we're just going to console log that at this point. I'm just going to get rid of our old test stuff. So our code is a bit cleaner. We'll save this, and we can do our first kind of full functionality test on our complete, hopefully complete program. So we'll go 1, dog, cat, 2, 4, 5, and we hit enter. We get a couple errors, not an integer, because we gave it 1, dog, and cat. And then we get the number 11 summing up 2, 4, and 5. So it seems like it's doing pretty good. We can do a couple more tests on it. Let's give it just... Oh yeah, we need negative numbers, so we'll put a -6 in there. So 10 plus 13 minus 6, that seems like 17. What if we just go only negative numbers? Minus 10, minus 5, minus 6. So you get minus 21. It's looking pretty good. And again, our functions here are pretty simple, but the same principles can be applied to like a bigger problem. If we're breaking it down into these small steps and we do our testing correctly as we're building the small steps, when we bring everything together, often we can get a program that's working. And if we get an error at this stage, it's probably not from one of these functions not working, but in the way that we are calling or integrating them together. So for instance, you guys found that error that I had here. I was calling it on array arguments. I mean, that's not a real thing. Well, it is a... It's not a real thing, but say if I had called it on arguments itself, and then I went in here and I was like, oh, let's try and test it. And I get this. I have no idea like what the heck's going on here. But I know that I've tested each one of these functions individually. So my first step would be to look in how I'm integrating them together. And if I'm looking through here, then maybe I see that, okay, argument is being passed to some arguments. I should probably be passing it the list of integers instead. I change it and then test again, and my codes should be running through. I guess lastly, we can add everything, commit everything. Working code for node arguments. And then at this point, maybe I would want to do git push origin master. I have to give it my username and password because I didn't set it up with SSH. And we can hop over to GitHub. And we can see all the updated code for our sum program. Okay, so just a kind of quick overview on how we handled some things. We broke all of our solution down into small functions as we went, working with small steps. We were linting our code as we went. That kind of was covered for the most part by the linter I had running, but also, we were tabbing in, we were making sure that our argument or our variables had proper names, we were giving it nice spacing. Linting is, mostly for you as a programmer as you're going through it so that you can read your code nicely. It's not like I finish everything and then I'm going to lint after the fact, so when I send this code off to someone else, it looks nice for them. Like, that's nice for whoever else is looking at the code, but it's way nicer if we can do that as we're coding, so it's intuitive and looks clean, and we can look back through our code ourselves and not get confused as we go through it. We avoided copy and pasting. I mean, we had the chance, maybe we looked up the isInteger function. Instead of copy and pasting, we typed in that new code ourselves. We were committing often. We used both console log and the debugger to understand our code. I maybe pretty sloppily use the debugger, but experiment with that and see how you can use it with your own code. For debugging, there's some tips and like maybe pitfalls that you can fall into when you're starting off. When you see those errors popping up in your code, like if we were to run this, we had this error here because we were calling this function wrong, and it's telling us that isInteger is not a function. Sometimes it's easy to see these, and they do look a little bit intimidating and confusing initially, but they provide valuable information on what's going wrong in our code, and we can use that to do a Google search like we did, or maybe just identify based on the message itself what we can do to improve. A typical path for like debugging when you get those things flash up is to like maybe Google a question. Stack Overflow might come up. You're going to look at the approach and see if that's valid there. But you can also get into a situation where you look on Stack Overflow and you're like, this is some new syntax or new things I've never seen before, and I have no idea if it's going to work. I'm not familiar with that. That can be frustrating, and thinking of how to interpret it. Just use that time to explore a couple different possible solutions and sources. Stack Overflow is good, but sometimes the answers at Stack Overflow are looking for like the best optimal way to solve a problem, or the like cleanest, most like elegant way to do that same problem in JavaScript. That can be helpful, but it can also be maybe not the first best step when you're learning how to like loop through an array or things like that. So look at different sources. If it looks overly complicated, that might not be your best resource to go and check into at the start. When you encounter an error in your code, it's broadly usually in two categories. You can have a parsing or runtime error, and that's just like this error that we saw here. The code itself actually wouldn't run because we were using syntax wrong. It flashes up and says like, oh, you can't do this. With that, we can look for errors in our syntax, and like we saw this path for Googling the correct syntax. But we can also run into logical errors. And a logical error is like an error where our code isn't breaking, but it's not doing what we want it to do. And that was here. When we were calling arguments instead of integer arguments, our code still ran, but it just outputted this kind of like jumble of numbers, and that was like not usable to us. These logical errors can often be like harder because there's no clear indication of where the error is coming from.
Computer's doing what you told it.
Yeah, exactly. In a lot of senses, it's not an error because your code and computer is doing exactly what you told it to do. It's you've just told it the wrong sequence of things to do. So you can start by maybe doing like a dry run of the code in your head, looking through, okay, if we are calling get arguments, let's just run through line by line what the code is doing, and see if it makes sense with our mental model of what it should be doing. The other thing that helps with these logical errors are, again, the console logs and debugger to make sure that along each step, the output is congruent with what you expect it to be. So we check that after numberize, we're getting a valid list of integers. And if we're not, maybe we ran into a logical problem before that point. Yeah.
Question about Git. So is there any way to go back to previous version if you find out the current version mistake or something?
Yeah, so the question is, with Git, is there a way to go back to a previous version if we find out that the current version is a mistake? Because we have this like noted, history of our commits. So actually, even if we look at our project here, we can look up at our commits, and I can see all these previous. Our first one, we initialized a sum demo. We broke down the problem. We finished our arguments function. So this is that like history that we were talking about. And each of these commits has this like ID associated with it. And this is what you use if you want to jump back to a specific place in your history. So say we want to go back to when I added just the numberize function, because these got me in a big mess. Well, you can use get to jump back to this point in your history, and that's one way to do it. In general, it's good to do everything you can to debug from the current save history. Don't too quickly just resort to jumping back to a working state. Give it a chance, and if it's really not working, that is a tool that you can use to get your code back in running order. We kind of went over this, but for parsing and syntax errors, get practice reading those messages. Mozilla Development Network, or MDN, is a really great resource, especially when you're starting off. So we can look in here and we can look up we used is integer, and we get this. The good thing with these documentation is they have a lot of examples that you can look through. They have the of course description of what the function or functionality that you're looking through does. They have a breakdown of the syntax, but like I said, there's lots of examples that you can go through. So this is sometimes, I would say, especially in these first couple of weeks, a preferable resource than something like the first thing that comes out of Google, like Stack Overflow or something. Yeah, so go through these debugging steps first, and then if it's really not coming down for it, that's what the mentors are there for. If you've been working on this problem for a bit of time, it's nice to get flex those problem-solving muscles and get practice reading these error messages and searching through documentation. Those are skills that every developer needs, but don't let it draw out longer than necessary. Always you can call on a mentor. Remember the 15-minute rule. If you've been working on something for more than 15 minutes and you're making no headway, call over a mentor. And then there's also kind of a skill set in working with mentors as well. And don't, you'll learn it as you go, but the note here is it's not helpful if you just say it's not working. Talk through the steps that you've already taken to solve the problem. Explain maybe the context of how you're encountering this error or what you're trying to figure out. Yeah, even asking for help is a skill that you'll develop throughout the course of the bootcamp. Other thing, I think you can also utilize mentors for more than just my code's not working. Code reviews are a great place for that. If you've finished an activity and you just want a mentor to kind of look over and give you any tips, flag them up, get a code review. The other really important thing that I think people should use mentors for, and sometimes maybe shy away from, is just to help you to understand concepts. So if your code is working and it's fine, it doesn't mean you can't call over a mentor. Call one over and say hey, my code is doing this thing at this point, but I'm not really sure on how it's doing it or why it's doing it that way. Or broader conceptual things just on a larger topic. Why do we use Node with JavaScript? What's the purpose of that? Those are questions that you can bounce off mentors as well. Lastly, we saw Node Debugger as a tool for looking through your code. There's another tool that can be helpful sometimes. This is a JavaScript tutor. Let's get it bigger for you guys. I would never code in here, but what you can do is you can take a section or your whole code and paste it within this JavaScript tutor. So I just pasted the function, but let's get a test. Integers. Test integers. And then we'll call some arguments on our test integers. And what this JavaScript tutor does is it really helps you to visualize how the code is being executed, in what order, and what data it's storing. So we hit visualize execution, it's going to load through it, but then it'll take us line by line through our code. So this red arrow here is indicating the next line that's going to be executed, and I can just hit forward to jump to the next thing. So the first thing, we see that test integers has been saved into memory as an array. And then sum arguments, which is a function, has also been saved into memory. And then we see that we've just called sum arguments, and we've given it the parameters test integers. And as we go forward now, we'll see it looping through our loop within sum arguments. So we get into the loop. We have a new variable total that's stored. We see the total being updated as we go through this loop. 6, 12, 19. And then finally, we exit out of the loop because we've hit all of these elements within the array. And we return 19. Use this as much as it's helpful to you. I think on more complex code, like flopping through and seeing what data is being stored and all of these things can be really like maybe overly too in-depth. But it is helpful to kind of see this red arrow bounce around and see which lines in order are called with your program. So if you want to get kind of like a peek into behind the scenes of how JavaScript is storing information and running through your code, use this. I have a link in the notes that I'll be sending to you. But your other tools, console log and debugger, are great as well. We're almost done. Just lastly, kind of a closing note. You'll be working on like continuing low tide today and through a lot of stuff in this week. Not all your assignments this week are going to have to do with low tide. Just for, I guess context on why am I doing this thing or whatever. Yeah, any questions before we wrap up on any of these kind of debugging tips or on any of the code that we wrote here? Like, why did we do anything a certain way from here or Calgary? If not, I will be sending you all of these notes. I'll also be giving you the code we went through if you want to look through it after the fact. And I'll be around for the rest of the day if you have any questions on the lecture or any of the notes. Calgary, you can hit me up on Slack anytime if you have a question on this lecture or any other lectures as well. But thank you guys. Have a great rest of the day. And yeah, let me know any questions that come up.